Welcome to part 2 of the Unlocking Conservation Innovation Grant Insights webinar series. The purpose of these webinars is to share insights from nutrient-led third-party technology evaluations that were conducted under our 2020 NRCS Conservation Innovation Grant Award. I'm Wendy DeVede, Manager of Sustainability Initiatives here at Nutrient, and in today's webinar, we will be exploring decanter centrifuge technology. Nutrient was founded in 2015 to help farms identify ways to reduce their environmental footprint while making it economically viable for them to do so. Our forward-thinking members include milk cooperatives and dairy organizations representing nearly all U.S. dairy farmers. In 2020, Nutrient received nearly $700,000 from the NRCS to evaluate 15 technology systems and practices, with the aim to demonstrate how these systems reduce the environmental impact of dairy manure with a focus on water quality. Our goal is to improve access to EQIP funding for innovative technologies under Conservation Practice Standard 629 and other associated standards. Partnering with universities nationwide, we collect samples, document the results, and produce comprehensive reports. These reports will be shared with the NRCS and the dairy industry to encourage adoption of sustainable dairy practices. With that, I'm excited to introduce Jeff Porter, Technical Advisor here at Nutrient and an ag engineer with an extensive background working for the NRCS, where he served as the leader of the National Animal Manure and Nutrient Management Team.
Thank you, Wendy. Greetings, everyone. It's a pleasure to spend a few minutes with you today talking about manure management and waste separation with the focus on centrifuge technologies. I want to give a special shout out to our partners in Colorado for assisting in this evaluation. First, we want to thank Centrisus for allowing us the opportunity to evaluate one of their centrifuge units, and to Deer Valley Dairy for providing access to their operation to see how the centrifuge fits in with their overall manure management program. Finally, I want to thank Morgan Community College for collecting the samples and developing the final report showing results and trends of this study. This image provides an overview of the manure management treatment train for this dairy. Manure is flushed from the freestall barns into an initial holding area. Following agitation, the influent is passed over an inclined screen and roller press, separating out coarse manure solids, which are stacked for later use. Liquid effluent flows into another storage area. The resulting liquid effluent is again agitated, creating a fairly homogeneous material. This liquid is then sent to the centrifuge. Due to the centrifugal forces of the centrifuge, additional and finer solids are removed from the liquid stream. These solids are also stacked for bedding or land application. The resulting effluent flows into a settling pond to capture additional solids. Liquids then flow into the final stage storage. This liquid is used for flushing the freestall barns and for application of manure nutrients through a center pivot irrigation system. It's important to remove a majority of the solids for the irrigation system to operate properly and reduce the likelihood of nozzle plugging. The unit evaluated for this project was a Centrisus CS30-4 centrifuge. And on this slide, we see a number of the specifications outlined for this unit and for other Centrisus centrifuges. The various Centrisus centrifuges can handle flow rates up to 700 gallons per minute, which can accommodate the manure from dairies of up to 10,000 cows. Units can be placed in parallel for even larger dairy operations. As mentioned in the previous slide, centrifuges can separate finer solids than other commonly used waste separation technologies such as inclined screens and screw presses. And as will be seen in the evaluation summary, higher concentrations of nutrients are also removed with the finer solids. The unique feature of this technology is due to the centrifugal forces applied, which are up to 3,000 times or more of gravity. Solids are moved to the outer edge of the centrifuge, while the liquids are collected in the center of the unit. Let's take a closer look at a centrifuge schematic. Here we see the cross-section of a two-phase centrifuge centrifuge. As seen on the right side of the image, manure influent is fed into the centrifuge. The solids, which are heavier than the liquids, settle against the rotating bowl wall and are discharged from the unit. The high centrifugal forces increase the solid separation efficiency. The lighter liquid flows out of the effluent or the centrate discharge to the liquid storage area. Due to climatic conditions, considerations should be made as to whether technologies should be protected from weather and cold temperatures. For this site in Colorado, both the inclined screen and centrifuge are located in a building. Depending on the number of technologies implemented, adequate storage and number of waste storage units for both solid and liquid components are needed. Most manure feedstocks can be fed through a centrifuge. This includes both raw manure and anaerobically digested manure. Now, if sand is used, it is important to remove as much of the sand as possible prior to utilizing the centrifuge. See, the grittiness of the sand can cause damage to the unit if it is not removed. Due to the high rotational speed of the centrifuge and other operational parameters, one must follow the manufacturer's operation and maintenance schedule to maintain optimal performance. Now that we have a basic understanding of the setup at Deer Valley Dairy, let's take a look at some of the data that was collected during this evaluation. Morgan Community College collected 5 different samples 3 times a week over a 15-week period for a total of 45 samples. 2 solid samples were taken, one from the incline or slope screen and the other from the centrifuge. 3 liquid samples were also taken. The first was from the raw manure entering the incline screen. This provided a baseline for the evaluation. Next, liquid coming from the incline screen, and the final sample included liquid from the centrifuge following solid separation. Weekly samples were sent to A&L Laboratories in Fort Wayne, Indiana for analysis. Results were then returned to Morgan Community College for evaluation. Now, for this study, virtually every nutrient increased or was enriched in the solids following the centrifuge. Most notably, phosphorus increased nearly 4 times in the solids from the centrifuge compared to those in the inclined screen. This can be seen in the reduced phosphorus amount in the liquid fraction following the centrifuge compared to both the raw manure and liquid after the inclined screen. Phosphorus generally attaches to solids, and by removing finer solids, a greater percentage of the phosphorus as well as other nutrients are removed from the liquid stream. Take note of the image on the right. This shows a comparison between the inclined screen solids and the centrifuge solids. The lighter colored, coarser material came from the inclined screen, while the finer textured, darker material from the centrifuge is shown on the left. Just by visual inspection, one can deduce that more nutrients are removed following the centrifuge. Even though some nutrients are removed by the inclined screen and centrifuge, there are still valuable nutrients in the liquid stream, which can be land applied for crop production. Now, there's a lot of information on this slide, but I just want to focus on a few things. Here we see the results from the inclined screen, coarse solids, and the centrifuge, the fine solids. The arrow points to nutrient enrichment of key elements in the fine solids. So as can be seen, all nutrients except for sodium increased, and in many cases increased significantly. The moisture content from the centrifuge is significantly lower than the average content from the inclined screen, which shows the impact of the high centrifugal forces in separating solids from the liquid. Now, I want to highlight just one of the parameters that was evaluated in this study. This image shows the significant difference between the phosphorus level in the fine solids compared to the coarse solids. This improved separation occurred without the use of polymers. And if polymers were added to the waste stream prior to the centrifuge, significantly higher percentages of nutrients would have been retained in the fine solids portion. The amount of nutrients removed to the solids would vary depending on the type and the amount of polymers used. Now, here we're looking at the averages for the samples taken for the 3 liquid sample locations. As can be seen, the vast majority of the parameters evaluated decreased from raw manure, liquid 1, to the liquid from the centrifuge, liquid 3. There were small increases in ammonium and potassium, while sodium remained constant across all 3 liquid samples. Now, it should also be noted that the moisture content increased between the 3 liquid samples, which would be expected through waste separation. From this evaluation, we saw that the centrifuge performed consistently throughout the study period and that a high percentage of the solids were removed from the liquid waste stream. The relatively high nutrient content of the centrifuge solids and lower moisture content allows for this material to be transported more economically and over greater distances for land application as an organic fertilizer for crop fields. As mentioned earlier, the reduced solids content in the liquid effluent provides additional opportunities and options for land application, including center pivot systems. Now, as mentioned earlier, the only sampled element not reduced in the solids portion with the centrifuge was sodium. It is theorized that the liquid, or the water, would break the sodium salt bond and be surrounded by water molecules, making it more difficult to separate from the liquid by the centrifuge. Use of the centrifuge reduced the solid size and content, along with the nutrient load from the other measured elements in the final liquid effluent. Now, based on the results of this evaluation, use of centrifuge technology could benefit dairies in numerous ways. Let me highlight and reiterate just some of those findings. Higher concentration of nutrients are removed in the solids portion through the use of centrifuges as compared to other technologies such as vibratory and inclined screens. The high centrifugal forces removes more moisture from the separated solids, making it more stackable, and provides other benefits related to land application and other potential uses of the solids. From a land application standpoint, solids can be transported longer distances more economically since less water is being transported. Also, by removing more and finer solids, this allows the remaining liquid to be more effectively utilized for land application. And if part of the overall manure management system, can potentially improve the performance of flush water systems. Use of a centrifuge technology can help to improve a dairy's environmental sustainability. It can provide more opportunities for uses and applications of the solid and the liquid components. Improved nutrient partitioning can also help to balance the manure application rates to the crop nutrient requirements. For future research, it would be beneficial to evaluate nutrient enrichment factors by optimizing technology performance and looking at the impact of utilizing polymers to further enhance separation performance. Now, even though we have touched on many of these points throughout this presentation, let's look at some of the environmental benefits. Now, with the centrifuge, finer solids are separated from the liquid waste stream. Since phosphorus tends to attach to manure solids, a higher percentage of the phosphorus is removed with the centrifuge, up to 4 times more when compared to the inclined screen. Now, this can be especially beneficial for crop fields that have phosphorus-based nutrient management plans. The nutrients in the manure solids can be composted or directly land applied. In either case, this material can be a valuable organic fertilizer. Reducing the nutrient loading in the liquid effluent can reduce the leaching and runoff potential of nutrients from crop fields. Solids removal from flush water can improve performance of flush systems. This can reduce the amount of fresh water required to maintain flush system performance. And finally, greenhouse gases and odors are reduced as the amount of solids are removed from the liquid waste stream. Okay, let's change gears just a little and spend just a few moments looking at some of the financial aspects utilizing centrifuge technologies. First, what is the system going to cost? For many, that is the bottom line. Well, it depends on a number of factors, but let's just look at animal numbers. As would be expected, the capital cost increases as the number of animals increase. Based on 2023 data for the Centrifuge centrifuge, an operation with 1,000 milk cows would have an estimated installation cost of about $400,000. And for 10,000 cows, approximately $750,000. But it should also be noted that due to economies of scale, the cost per animal decreases as the number of animals increase. Now, there are other operational costs to consider. Here we see estimated average annual operational costs for 10,000 cow dairy. There are electric needs to keep the centrifuge operating and also maintenance cost. Since there are so many moving parts, it's important to follow the operation and maintenance plan provided by the manufacturer to keep the system operating efficiently and properly. As shown here, one of the recommendations is to have the centrifuge rebuilt annually. Now, even though there is a cost for operating a centrifuge, there's also a potential for revenue streams. The solids can be utilized in numerous ways. They can be converted to soil amendments or composted. This material could be land applied or sold through various markets. The solids could be used as manure solid bedding. Use of this material could offset the cost of purchasing other bedding such as sand or sawdust. Thermochemical technologies such as gasification or pyrolysis could be used to generate biochar, syngas, and or heat. Anaerobic digestion would be another potential technology that could be implemented to produce electricity or renewable natural gas as a revenue source. Anaerobic digestion, cap and flare practices, thermochemical systems, and even solid liquid separation have the potential for obtaining carbon credits by providing additional income. But by removing more of the phosphorus from the liquid phase stream, the nutrient balance will likely be more in line with the crop nutrient needs. This could reduce the amount of commercial fertilizer required for crop production. Removal of solids also allows the liquid to be pumped longer distances and utilized in low pressure center pivot systems, which can lower overall land application costs. And as my final topic, I want us to outline some of the items to consider when looking at implementing a centrifuge waste separation system. When looking to invest in technologies on a dairy, there are many items to consider. First, does the application fall in line with the goals and the objectives of the operation? Does it help to move the dairy forward economically, environmentally, and sustainably? What kind of weather conditions are encountered in your area? Does the technology need to be enclosed to protect it from precipitation, freezing, or excessively high temperatures? Many technologies may have electronics that need to be protected from the elements. Are you looking to change your bedding or enhance the bedding that you're currently using? Have you implemented any other technologies such as core solid separation on your operation? What modifications, if any, will need to be made by adding a centrifuge to your waste management system? How much land do you farm? And how much commercial fertilizer is required? Would modifying your operation with a centrifuge improve the utilization of the available nutrients that are found in the manure for land application and potentially reduce the amount of commercial fertilizer that's needed to meet the crop needs? If this technology is implemented, how will the solids and liquids be utilized? Are you looking at additional revenue streams? Now, these are just a few of the questions that one might consider when looking to install a centrifuge or other technology as part of the waste management system on your dairy. At this time, I would like to give control to Corinne Brown. Corinne.
Thanks, Jeff. Hi, everyone. My name is Corinne Brown. I'm an analyst in sustainability research and initiatives with Nutrient, and I'm going to walk you through some of the various resources that Nutrient offers. We have many experts on our team who are happy to spend time with you as a farmer, cooperative, or other industry stakeholder looking to learn more about additional on-farm sustainability practices or to hear more about Nutrient. The Nutrient website, or www.nutrient.com, houses many resources, one of those being the Nutrient Solutions Catalog, which is an online collection of solutions including manure additives, NRCS practice standards, and hundreds of service and technology providers. Nutrient's Resource Library is a place where audiences can find a compilation of webinars, peer-reviewed articles, white papers, and more. Nutrient's blog hosts various articles and posts about recent dairy industry happenings, specifically pertaining to dairy sustainability. You can also locate various webinars on the Nutrient LLC YouTube channel, including another video part of this webinar series on dairy composting. Nutrient's quarterly newsletter is also a great resource to learn about Nutrient's latest updates in dairy sustainability news. You can use the QR code on your screen to subscribe to our newsletter for timely updates in industry news, as well as access Nutrient's contact form to get in touch with us. If you're curious about the 14 other Nutrient SIG technology evaluations taking place, visit Nutrient SIG webpage where you can view project materials such as vendor snapshots, evaluation summaries, comprehensive reports, webinars just like this one, and informative videos. Do note that evaluations and deliverables will be added to the webpage as they are completed, and not all technologies will include all of the listed deliverables. I would like to give a very special thank you to our partners on this project, including the USDA NRCS, our university research partner, Morgan Community College, for their work evaluating this technology, Deer Valley Dairy for allowing the evaluation to take place on their farm, and Centrisa CNP for collaborating with Nutrient as the vendor of the evaluated decanter centrifuge. We'll now jump into our Q&A session. Accompanying me will be speaker Jeff Porter.
Greetings.
Let's dive in here. So first question, why did Nutrient choose to perform an evaluation on a decanter centrifuge? And what sparked the interest in including this technology in Nutrient SIG evaluations?
All right. Well, thanks for that question. Yeah, as we think about there are so many different types of separation technologies that are available, and as we look at different dairy operations, they have different goals and objectives, and they need to look at removing, different components, different amounts of solids. So we needed to be looking at different technologies so that we could help meet those goals and objectives of those varying operations. If you're just wanting to get the core solids, maybe an incline screen or a screw press would take care of it. But if you're wanting to get more nutrients or you're wanting to get more of the solids out of your liquid stream, then maybe looking at technology such as a centrifuge is something that would be needed by certain dairies. So that's why we wanted to include this particular technology in as one of the technologies that we're evaluating through our Conservation Innovation Grant.
All right, thank you. Next question, is it difficult to implement a decanter centrifuge into an existing manure system? So, for example, if a farm uses, say, sand bedding and a simple scrape collection system that leads into a lagoon or a holding pond, from this point, what would need to be implemented to incorporate a decanter centrifuge into their manure management system?
Sure. That's one of the things you got to think again. How is this dairy operating its operation? I mean, what are they doing? What are they using for bedding? How are they collecting the materials? All those types of things have to be taken into account. Like with the centrifuge, as we discussed in the information that was provided just a little bit ago, sand can really create some problems for a centrifuge and actually for a lot of the mechanical systems. So if you had sand, you need to find some type of a technology to remove as much of the sand as possible, so that you wouldn't have as much operation and maintenance requirements for your centrifuge. You'd also have to see, do you have the site conditions that would allow you to install a system such as a centrifuge? Do you have enough, and I'm going to call them storage areas or holding areas, if you need to transfer, one liquid to another, based on, you need one liquid to go into the centrifuge and another liquid for it to come out of the centrifuge. How many different technologies do you have? And then how many of those different storages do you need to take into account? So what I like to do on these is I like to look at it from a system standpoint, and then take the individual unit processes, such as a centrifuge. I say, okay, where's this going to plug into the system? Okay, are there any issues or things that could impact with putting this technology here? And if there is, okay, how do we address that? Or do we need to move it to another location? Do we need to put it somewhere else within the system so it would perform properly? So again, my answer is it depends, because you've got so many different factors that can contribute to the overall operation of this dairy. So if you're installing a technology, you have to, number one, know what features does it have, how is it going to perform, and then how can you plug the other components into that so that you have a smooth and an efficient operation.
All right. So if someone were to have a question on if you would think a centrifuge would be right for their system, could they reach out to you?
Sure. I mean, that's definitely that's why Nutrient exists. We're here to help producers in guiding them in their decisions. Again, it's not our decision to make. It's up to the individual landowner. We will provide the information that we have. We also have the catalog, as you talked about just a little bit ago. They could go in the catalog, look at the information that's outlined there. We are going to have these webinars. These things are available as well. They can look at that information to help them to make an educated decision as to what is going to work best for their operation.
Great. Next question, what is the turnaround time for a finished separated product from the time the manure slurry enters the centrifuge to then leave the centrifuge as liquid effluent?
Well, you're going to hear this a lot, is it depends. It depends, again, how many unit processes are you using? So let's say the centrifuge is the only separation technology that you have. You're using manure solids for bedding. Basically, the material would go into a holding area, and then from that holding area would go to the centrifuge, and it would you'd have to meet the criteria on what liquid concentration do you have? Does it meet the requirements of the centrifuge? And if it does, I mean, you're going to get I won't say instant results or instant solids and liquids out, but it's going to happen very quickly. Again, depending on the number of technologies. If you just have one, you're going to get fairly quick results. This unit can operate up to 700 gallons or more per minute. So again, with that type of a flow rate, you're going to get fairly I guess, for lack of a better, fairly instantaneous results in your separation if you're feeding directly to the centrifuge. But again, if you have another technology such as a screw press or inclined screen, it would have to run through that technology first, then go from there to either a storage unit for further agitation to get everything in suspension, then into the centrifuge. But it can, you can get your separation to occur fairly quickly with the once it gets to the centrifuge, that separation happens fairly quickly.
Okay. Is a centrifuge used for fine solid separation rather than coarse solid separation, or can it be used for both?
You know, again, that's I think the last thing that you added there, could it be used for both? Yes, it could. And I've seen systems where that's the only separation technology they have,
Okay.
is that they're only using a centrifuge. But again, it depends. It depends on what are again, you're probably going to get the listeners are going to probably get tired of hearing this. It depends on the operation. What are their goals? What are their objectives? You know, do they want to do a coarse solid separation for their bedding? Let's say they do an inclined screen. They can use that for their bedding because that's going to be your coarser material, lower nutrient contents. Then you could run the material through the centrifuge like we did on this particular farm. You're going to get a much higher nutrient content, much finer solids are going to be coming out with the centrifuge. And so those could be, you know, land applied, have a higher nutrient content, could be used for your nutrient management plan. But again, you could just use this technology by itself. You would get the coarse and the fine solids would be mixed together. Your results are going to be very similar to what we had with this particular study. It's going to be a combination of the inclined screen and centrifuge together. Basically, what you get there is what you will get through the centrifuge by itself. So again, I'm going to say it depends. What are you wanting to? What are your goals? What do you want to use the solids for on your particular operation?
Okay. Does EQIP currently provide funding towards decanter centrifuge technology?
The answer is yes, but and let me give you understand the clarifier on that. They have a waste separation payment that's available.
Okay.
Now, it depends on the state as to, again, what the payment rate will be, but it also depends on the state or the region as to what types of separators they're focusing in on. For example, I was looking here at Colorado for 2024. They have a payment schedule for a mechanical separation facility for X dollars. Then they also have another payment scenario for a medium-sized mechanical separator for an amount that's higher than the mechanical separating facility. So some states may have one or two technologies that they're focusing in on the waste separation, and some states may have multiple. They could say, okay, this is going to be for inclined screen, or this is going to be for a screw press, this is going to be for a centrifuge, or they say it could be for any separation technology. Here's the payment rate for that technology. So again, it depends on the state as to how they have separated those. That's kind of strange. How they have separated the separation technologies into different categories and groups.
Yeah.
So you need to talk with your local NRCS field office, and they will help you to understand, you know, what kind of payments are available and whether you qualify for those payments within within the EQIP payment schedule system.
Okay. Yeah, that certainly emphasizes the importance of reaching out to your local office and contact.
Oh yes, definitely, definitely. Yep.
All right. Well, that is the end of our questions, and I believe concludes our Q&A session. Feel free to refer back to those resources slides and contact Nutrient for any follow-up questions you may have. Thanks, Jeff, for all your valuable input regarding Nutrient SIG evaluation. Do you have anything you'd like to say?
No, just thank you for the opportunity to share with the group. I think we've gained some really valuable information, and I would just encourage the folks to continue, you know, looking at our website on Nutrient, because we'll be adding more of these webinars, and the results from the studies that we're doing will be added periodically throughout the next year or so as well.
Yeah, certainly keep an eye on that CIG webpage on the nutrient website that I referred to earlier. All right, thank you everybody for listening.
Take care.